Our next lesson is called Justify the Steps to Solve an Equation, Properties. In the top box, you're going to see a quick review of the properties that we will be using during this lesson to justify each step in our solving. So the first one you're going to see here is properties of equality. Properties of equality exist for all four operations: addition, subtraction, multiplication, and division. If you perform an operation on one side of the equation, remember you always also have to use it on the other side of the equation to keep the equation equal. That's why these are called properties of equality. We have the distributive property. So remember, for the distributive property, the number on the outside gets multiplied through the set of parentheses on the inside. We also have commutative property. Remember that word commute in there, which means to move. Okay, this is where we switch order. Okay, so you'll see the example 3 plus x equals x plus 3. And then lastly, we have the associative property. Remember, associate, who you associate with is your group. So this is where your groups are changing. What's inside the parentheses is different on one side than the other side. So keeping those properties in mind, we are going to look at some solving of equations. They have been solved for us, and it's going to be our job to justify each step in the solving process. So let's start with example 1. We're starting with the equation 2x plus 9 equals 21. The steps in solving the equation are shown below. We're supposed to justify each step, which means explain it using a property. So if I look at this as my original equation right here, and now I look at step 1, I can see that we have subtracted 9 on both sides of the equation. So that would be the subtraction property of equality. Whatever you do to one side, you must do to the other side to keep the equation equal. Then when I look at step 2, I see that I am multiplying by 1/2 on each side in order to solve this and get that x is 6. So that would be the multiplication property of equality. I multiplied on both sides to keep it equal and therefore was able to solve and get x equals 6. So there's a short example of what we will be doing in this lesson. Now let's take a look at example 2. We're starting with this equation that you see here at the top. Very involved. I see parentheses in there. Definitely some like terms that will probably be combined eventually. So we're going to look through our steps and justify each step. So if I look at the original compared to step 1 now, I see that the 3 has been distributed to the x plus 2 to get 3x plus 6. And also the negative 2 was multiplied by x plus 7 to get negative 2x minus 14. So this justification is the distributive property. Now you see that I am writing out the full name of these properties. That is important. When you get to Regents exams, you cannot abbreviate. You must write the full proper name of the property. Now looking from step 1 to step 2, trying to notice what has changed, I see that we used to have 6 and negative 2x. Now I have negative 2x and positive 6. So the order has changed. So that is commutative property. And I'm going to put a plus sign in parentheses showing you that it was addition, commutative property of addition. So the order has changed. Now looking at step 3. They're showing combining like terms in a way that we may not necessarily show when we're combining our like terms. We tend to code them, like put a circle around 3x, put a circle around negative 2x, and add them in our head. But essentially what you really are doing is you are grouping them and factoring out the x. So if you take a look at this, this is actually reverse distributive property. The x has come out and the 3 and the negative 2 have remained behind in the set of parentheses. So I'm referring to this section here compared to this section here. So this is an example of the distributive property. And you can see what they've done is then simplified that to get this step right here. So now moving on, going from x minus 8 equals 4x plus 7, below, I can see that we are subtracting 4x and adding 8, subtracting 4x and adding 8. So we have both added and subtracted to both sides of the equation to keep it in balance and keep it equal. So this is the addition and subtraction properties of equality. Moving on to step 5, I notice a change in the order. I had negative 8, negative 4x, now I have negative 4x, negative 8. Same thing happened on the other side. The 7 and the negative 4x have switched positions. So the order has changed. That is commutative property. Again, of addition. At the next step, you see something similar that happened in step 3. To show our like terms, we put the x minus 4x and we take out the x by doing reverse distributive property so that we can combine our like terms. So this is distributive property. And then lastly, going from this equation, negative 3x equals 15, you can see in step 7, we have divided both sides by negative 3. So that would be the division property of equality. Okay, now let's move on to example 3. We're going to consider the equation that you see up at the top. I'm going to box it in again so you can see where we're starting. And again, we will look at the steps used to solve and justify them using our properties. So looking from the original to our first step 1, you can see that negative 3 has been distributed through the parentheses to get negative 3x minus 3, and 2 has been distributed to get 2x plus 8. So this is a use of the distributive property. Now in our next step, everything looks the same until I get to here. Minus 8, minus 8. We have subtracted 8 from both sides of the equation in order to solve it while also keeping it in balance. Remember, whatever you do to one side, you must do to the other. So this is the subtraction property of equality. In step 3, they've found our like terms and reverse distributed or factored out that x so that we know we're really combining a 5 and a negative 3 to get 2x. So this is an example of the distributive property, just kind of in a reverse way like we've seen in previous problems. In step 4, we have subtracted 2x from the left side and also the right side. So that is, again, the subtraction property of equality. And then in our last step, you can see that the negative 11 and the negative 2x have now become negative 2x and negative 11. So the order has changed, making this commutative property. And again, this was of addition. So now in part B, it says the final line of this set of manipulations is a very strange statement. So let's take a look at what they mean. What do they mean by strange statement? Well, you can see here, and they've rewritten it here, that we got negative 11 equals 0. So first of all, is this a true statement? Is negative 11 equal to 0? Absolutely not. So is this a true statement? No. Could any value of x make this a true statement? So think about it. The x's are completely eliminated. So it doesn't matter what we pick for x, they're going to disappear. And those two numbers, negative 11 and 0, are never going to equal each other. So there is no value of x that could make this statement true. So C says, what do you think this tells you about the solutions to this equation? For example, the values of x that make it true. So because x is eliminated, and the remaining numbers are not equal, this is no solution. Okay, so this is an example of an equation that has no solution. So now let's move on to our last example, which is example 4. Consider the equation. We're starting up here. It says, A, solve this equation by manipulating each side of the equation as we did above. What does its final strange result tell you? So knowing the steps that we've been practicing in solving an equation, we know the first thing we should look for is distributive property. We do see that there, so this is going to become, and I'm just going to work down here, 7x plus 2x plus 10 equals 9x plus 10. After we check for distributive property, we're supposed to look for like terms on each side separately. So I'm going to look at the left-hand side and see that I have like terms of 7x and 2x, which makes 9x plus 10. On the right-hand side, I do not have any like terms. Then I get rid of variables on both sides. I'm going to use my subtraction property of equality to subtract 9x from each side. Remember, I need to keep it in balance. So I end up with 10 equals 10. So what does this final strange result tell you? So do you see that the variables are totally eliminated, but this time you have two numbers that are actually equal to each other. So no matter what value of x I pick, they're going to be eliminated anyways, and that statement 10 equals 10 is always going to be true. So this tells me that all values of x make this true. So this is infinitely many solutions. And we have discussed this in previous lessons, just taking a look at it from a different way. So lastly in B, it says test your conclusion by picking a random integer, or really any number, and showing that it is a solution to the equation. So we can pick any number we want. I'm going to pick x equals -3. I'm going to take their suggestion and pick an integer. And I'm going to go back up to my original equation, which is 7x plus 2 times x plus 5 equals 9x plus 10. And I'm going to substitute in x equals -3. Every time I do that, remember it needs to go into a set of parentheses to show the substitution. Then I work my way through using order of operations. So this is 7 times -3 plus, I do parentheses first. So this is a +2. Now I could do all my multiplication. So that's -21 plus 4 equals -27 plus 10. -21 plus 4 is -17. And -27 plus 10 is -17. So I have showed that I've picked a random number and it absolutely works in this equation from example 4. So this concludes our lesson on justify the steps to solve an equation properties.